In this video, we will look at a few more risk measures other than value at risk. Okay, so here I list the definitions. The first is conditional tail expectation of x at level alpha. The second is tail value at risk, T bar. And the last is expected shortfall. So you can see all of them involve level alpha. So this alpha, just like in the case of value at risk, should be a number close to 1, for example 0.99 or 0.995, and x represents the future loss. So CTE is defined as the expected loss given that the loss is greater than the value at risk. And then T bar is given by the integral of the value at risk while treating P as the variable of integration. Okay, so we integrate P from level alpha to 1 and then divided by 1 minus alpha. Expected shortfall is the expected value of the shortfall. So why do we call this shortfall? So if you set your reserve to be the value at risk at level alpha, then this bracket plus this positive part is the shortfall. Okay, so if the loss amount is less than the reserve, we have enough money to pay and there's no shortfall. So the shortfall will be 0. But if the loss amount is greater than the reserve, then the difference will be the shortfall. So that's why this x minus the capital or x minus the reserve positive part is the shortfall. And then the expected value is called the expected shortfall. So in this video, we will focus on T bar. And then in the next video, we will describe how we can calculate CTE and ESF by using some relationship with T bar. So before we calculate T bar, okay, so let's look at the geometric meaning of this integral. Okay, so here, remember in the previous video, we have 3 cases when we draw the CDF curve, depending on whether we have one intersection, no intersection, or the horizontal line meets a horizontal portion of the CDF. So now let's look at the first case. Okay, so alpha is here, we draw the horizontal line. Now, what is the meaning of this integral? So P is a number between alpha and 1. So let's say P is here. Okay, and then when we draw the horizontal line, then the length of this black line is the value at risk of x at level P. And now we need to change P from alpha to 1. Okay, and basically the integral here is to add up all these kind of horizontal bars. Okay, so that means this integral is simply the total area of the shaded region. Therefore, T bar of x at level alpha is simply the area of the shaded region divided by 1 minus alpha. Okay, so that means if you want to find T bar, we can first find the area of the region bounded below by level alpha and bounded above by 1 and also bounded by the curve. Okay, so we find the area of the region and then divided by 1 minus alpha. Case B is similar. So this time when we draw this horizontal line at level alpha, we encounter a jump, so there's no intersection. But we know that this point, okay, so this point is value at risk. Anyway, the integral is still given by the area of the shaded region. The region is the same as before. It is bounded below by level alpha, bounded above by level 1, and on the left hand side bounded by the CDF. Okay, so bounded by the CDF curve. So we look at this region, find the area divided by 1 minus alpha. That will be the T bar. The final case is basically the same. So this time when we draw the horizontal line at level alpha, we encounter a horizontal portion of the CDF. So anyway, the region above level alpha, below level 1 is just the integral. Okay, so T bar is just the area of the region divided by 1 minus alpha. Okay, so in all 3 cases, you can see T bar is area divided by 1 minus alpha. Okay, and the area corresponds to the region bounded below by alpha, above by 1, left hand side by the CDF. Okay, so we find the area of the region divided by 1 minus alpha, and that will be T bar. So we look at one discrete example. Okay, so here x can take 4 different values, 100, 200, 300, and 400. And these are the probabilities. And I want to find value at risk at level 0.95 and also t-var, tail value at risk at level 0.95. So we first draw the CDF. So we know that because x is discrete, so the CDF is piecewise constant. Piecewise constant. It jumps at these 4 points, 100, 200, 300, and 400. And the size of the jump corresponds to the probability. Okay, so here the size of the jump is 0.4, the size of the jump is 0.5, and then here is 0.08, and here is 0.02. So first find value at risk, var at 0.95. Okay, so this time we look at the horizontal line at 0.95, and we see that there's no intersection because of the jump here. So the CDF jumps at this level at 300. Therefore, the value at risk at level 0.95 is 300. So basically, if you look at the graph again, if I change the number from say 0.95 to 0.96, the conclusion is the same. When you draw the horizontal line at 0.96, again, no intersection because of the jump at 300. So the 96% VAR is still 300. And similarly, 97% VAR is still 300, etc. Now, how about t-var at 0.95? So this time, we need to find the region. Find out the region here. Okay, so the black region, okay, so it is bounded below by 0.95, bounded above by 1, and bounded by the CDF curve. Okay, so we need to find the area of this shaded region. Okay, so the 95% t-var is the area of the black region divided by 1 minus alpha, 1 minus 0.95. Okay, so you can easily find out the area of this region. And if you do the calculation, you get 340. Alternatively, if you don't use the area method, you can use definition. So by definition, the 95% t-var is the integral of, this is not t-var, this is var. Okay, so this is a mistake. So it is the integral from 0.95 to 1 of the value at risk of x at level p, and then divided by 1 minus 0.05. And for this integral, we chop it into 2, from 0.95 to 0.98, and then from 0.98 to 1. So we first need to find out the value of the var, value at risk, not t-var. Okay, so just value at risk. We need to find out the value of the value at risk at level p, for p between 0.95 and 0.98. So from the graph you can see, for any p between 0.95 and 0.98, the value at risk is 300. Okay, so it equals 300. And in the second integral, okay, we need to find out the value of the value at risk at level p, p between 0.95, 0.98 and 1. So in the graph here you can see, if p is between 0.98 and 1, when you draw the horizontal line, okay, so you can see there's no intersection because there's a jump here at 400. So value at risk equals 400. Value at risk equals 400 for p between 0.98 and 1. Okay, so now we can calculate these two integrals, and then we will get 340.